Hi everybody, welcome back. Today I'm going to go over the Cournot model, and this is a model used in oligopoly situations. It's a game theoretic model. It actually predates game theory. It's from the 1800s, but we can use it in the same way we would use a game theoretic model or a game theory model because it has all the elements of a game theory problem. It outlines strategy, and it lets us know, it helps us see how firms are interdependent in an oligopoly situation. And so this is specific to Econ 170. This is specific to the antitrust section on oligopoly, but you can use it to help understand any Cournot model because the solution for how to get to the answer to the problem stays the same. So how do we solve a Cournot model? Well, first we take the inverse demand function, and we're going to turn it into a residual demand function. And I'll show you how to do that. Then we want to find the residual marginal revenue curves or marginal revenue functions. We set those residual marginal revenue functions equal to marginal cost to get our best reply or best response functions. And then we use those best response functions, we insert them into each other to get our equilibrium quantities. And that's the big thing of the Cournot model. In the Cournot model, the strategy for each firm is their quantity we choose. So we find our quantities by inserting the best reply functions into each other. If that doesn't make sense, don't worry, I'm going to explain it. This example is taken from the Viscusi, Harrington, and Sappington book on economics of regulation and antitrust. In the 4th edition, it's on page 120. It's also indicated in figure 4.4. But the big idea there is that we have this demand function, P equal to 100 minus Q. And that's the inverse demand function because it's P in terms of Q and not the other way around. We also have a marginal cost, which is $40, which is equal to average cost. And then we can find the marginal revenue curve easily. One of the great ways we can find marginal revenue is to solve for our measure of marginal revenue being marginal revenue equal to P plus change in P divided by change in Q times Q. So in that case, what we get is marginal revenue is equal to the inverse demand function. In this case, 100 minus Q plus the slope of the inverse demand function, -1, times the quantity we're looking for, which simplifies to 100 minus 2Q would be our marginal revenue curve. Going through it quickly. If you've got questions about it, let me know. You can also check out my 100B videos for a little review. But I'm just going through it quickly to show you how I'm going to derive those marginal revenue curves later on. So what we have up here is the monopolist, and I do ask you to graph the monopoly demand curve and then the marginal revenue curve for firm 1. So to do that, first of all, we want to break this inverse demand function into the oligopoly inverse demand function. And that just means we're going to have two firms with two quantities, Q1 and Q2. And that's because this big Q is the market Q, and these two little Qs are the quantities that each individual firm is going to produce. So now that I have this, I can do the first part, which is graph it. Big Q is the market. And then I've got, if firm 2 produces 10 units, what's the residual demand curve for firm 1? Well, it's going to be 100 minus 10 minus Q, or 100 minus Q1 minus Q2, where Q2 is 10, is going to be 100 minus Q1 minus 10, or Residual demand for firm 1 is 90 minus Q1. So far, so good. So we can graph that inverse demand curve. It's going to look like this. It's linear, so it's easy to graph. And then we want to derive the marginal revenue function. I'm running out of pens. Okay. And that's going to be the inverse marginal revenue for firm 1. The residual inverse marginal revenue is going to be 90 minus 2Q1. I know that's using that same technique I just showed you a little bit ago. And so I'm going to get a marginal revenue curve that looks like this, where it intersects the x-axis or the q-axis at 45. And then we want to impose our marginal cost curve at 40 and derive our Q1 star, our optimal quantity at that level. So Q1 is going to be determined by marginal revenue equal to marginal cost, or 40 equals 90 minus 2Q1, which I'm going to subtract 90 from both sides, and I'm going to get 50 is equal to add 2Q1 to both sides, and then divide both sides by 2. I get Q1 equals 25. Does that make sense? Hopefully. So that's the first part. If firm 2 produces 10, what would be the demand marginal revenue curve for firm 1? What would be Q1? Graph it and determine the outcome. That's easy enough. The problem is if we want to see what this firm is going to do for every possible Q2, this is a very time-consuming way to do it. So in order to solve a Cournot model without inserting every single value for Q2, we want to do the things I said before. Find the residual marginal revenue curves, set them equal to marginal cost in order to determine the best response or best reply functions, and then insert a best reply function into the other one to determine the equilibrium quantity. You can also graph those best response functions. And again, that's in the Viscusi textbook. So I want to take this inverse demand function and derive the residual marginal revenue function for each firm. So there's going to be a residual marginal revenue function for firm 1, and it's going to be 100 minus 2Q1 minus Q2, and there's going to be a residual marginal revenue function for firm 2, excuse me, and that's going to be 100 minus Q1 minus 2Q2. The idea here is that in these residual marginal revenue functions, the quantity of the other firm is not the quantity we're interested in. We're interested in the quantity for our firm. So for firm 1, it's Q1. For firm 2, it's Q2. And that's the slope that is doubled when we derive that marginal revenue function. Again, it's a little, I'm glossing over it. So if it doesn't make 100% sense, reach out to me and let me know, or go back and check your intermediate micro notes on deriving marginal revenue curves, or ask me to make another video. Okay, so now we have 2 marginal revenue functions for our 2 firms. And then we want to set both of them equal to marginal cost. The marginal cost is the same, so we're going to get mirror image best response functions. So to get the best response function or the best reply function, we're going to set marginal revenue equal to marginal cost. So we're going to say 40 equals 100 minus 2Q1 minus Q2. Subtract 40 from both sides, and we get 60. And then we're going to leave the Q2 and add 2Q1 to both sides. Now we're going to divide both sides by 2, and we get our best response function, or our best reply function. Q1 equals 60 divided by 2 is 30, minus 1/2 Q2 or 0.5 Q2. I know I'm going through it quickly. If you're having trouble with this, let me know. We'll do the same thing again for firm 2. So we're going to set their residual marginal revenue function equal to their marginal cost, which is still 40. So 40 equal to 100 minus Q1 minus 2Q2. And again, since it's firm 2, I'm trying to isolate that Q2. So I'm going to subtract 40 from both sides to get 60. Leave the Q1 here, add 2Q2 to both sides, and then divide both sides by 2. And I get Q2 equals 30 minus 1/2 Q1. So those are those best reply or best response functions right there. You can see they're mirrors of each other, one for firm 1 and one for firm 2, based on their marginal revenue curves and their marginal cost. Okay? Now we do the somewhat tricky part of inserting the marginal or the best reply functions into each other. And the way we do that is, you can see here, there's Q1 in terms of Q2 and Q2 in terms of Q1. The whole point of this is to see how firm 1's profits are a function of Q2, right? Their quantity is based on what the quantity of the other firm does. Since we're assuming in this game that everybody has perfect information, we can assume that firm 1 knows what firm 2 is doing and vice versa. So I can take this best reply function and take Q1 equals 30 minus 1/2, and then for Q2, insert this best reply function. 30 minus 1/2 Q1. Because Q2 is equal to 30 minus 1/2 Q1. And now I have 2 Q1, so I can solve for what Q1 is equal to and get the profit maximizing quantity for that first firm. So I'm going to distribute this negative 1/2 across. I'm going to get 30 minus 1/2 times 30 is going to give us 15. Negative 1/2 times negative 1/2 is going to give us plus 1/4 Q1 equals Q1. Now I'm going to subtract 1/4 of Q1 from both sides and get 3/4 or 0.75 Q1 equals 30 minus 15 is 15. Now divide both sides by 3/4 or by 0.75. You get Q1 equals 20. Cool? That's your answer. That's the profit maximizing quantity for firm 1. We can do the same thing for Q2, where we can say Q2 equals 30 minus 1/2, 30 minus 1/2 Q2, or we can take this best reply function and insert Q1 into it. You'll get the same answer either way. So if I take Q2 equals 30 minus 1/2 Q1 and then replace Q1 with 20, what do I get? 30 minus 1/2, 20 is 10. Q2 equals 20. And they should have the same amount because they have the same marginal revenue curves, the same best reply curve, and the same cost function and cost curve. So that's your Cournot-Nash equilibrium. Q1 equal to 20, Q2 equal to 20. Okay? So let me know what questions you have. Let me know what part you'd like to spend more time on. The big takeaway for this in terms of antitrust legislation and understanding oligopoly is how interdependent these two firms are. A slight change in the behavior of one firm is going to have an effect on the profits of the other firm. And that's the big idea. Okay? All right. Let me know what you think, and I'll see you next time.